power utility companies.
My name is Ming Feng. I'm the industry principal of APEC. For those of you who want to attend Dave Thompson seminar this afternoon, I'm sorry to inform you he is not able to come for his family affair. He wants me to say sorry for him. Okay, I'll start my presentation. We are going to talk about PI-AF and event frame used in the power industry. Especially I will talk about my favorite application of our technology for proactive and condition-based maintenance in power generation and T&D. I will show some example of use cases. This is called maintenance PF curve. Many of you may have seen this before. I believe this is very important. I like to use it to describe a common understanding of equipment failure. Every system or pieces of equipment has something that can be detected when its performance is degrading. It could be a slight change in temperature, a high vibration, a change in amps. The P point up there on the curve represents the time that change is detected. Every system or equipment will also have a point when it fails. That is the point F. The time between P and F is the opportunity for you to do condition-based maintenance. The farther up you can move the point of detection, that means I can detect P further on the left-hand side, then the longer opportunity you will have to commercially plan around the market, schedule the outage at the best financial time, and plan for parts and labor. You need proper instrumentation and real-time data availability on your critical equipment to have earlier detection of pending issue and move that up to the curve. Proactive maintenance is a strategy in which corrective, preventive, and predictive processes complement one another. Studies have revealed the average industrial plant perform more than 55% is the reactive maintenance. We all know reactive maintenance is very costly because we didn't plan for that, just react for that. So the cost may be 10 times over a normal planned work. So the study shows the top industry plant spend less than 10% on reactive maintenance. They do this by greatly increasing their use of data. Below is an industry best practice target goal maintenance mix. This target goal is economic balance by increasing predictive capability and optimized planning, preventive maintenance with CBM process to drive down the high-cost reactive issue. As you implement more data and predictive technology, you can assign this category to your work order system. You can then measure improvement over time as work span moves from reactive to predictive category. So many people, they implement PI. The first thing they want is to get a copy of a control room DCS display. This is good and very powerful, but the system should be used to develop specific visualization and information with maintenance in mind. Because the DCS display is always related to normal operation, very few with the maintenance. So a focus on critical equipment and parameter for condition, vibration, temperature, current. You can also transfer data and use in new, valuable way. By using out-of-the-box Pi system functionality, creating long-time equipment counter, compare the balance usage, schedule maintenance on condition, and systematic measure accumulate damage. Having this data drive notification to keep the right people informed, or will help increase speed and accuracy of the decision. PiAF is very valuable in power and utility industry. Having all information within the context of the asset have many benefits. By implementing AF with the structure that follow the process and system of the plan, allow template at the various level. For most thermal plan, we have the plan and then unit, and then system, subsystem. And equipment. Each level have associated element, relative display, calculation, summary from layers below. They driving notification to responsible people. Critical equipment could then at various level and can drive by common template. F can span multiple Pi system and business unit, provide a common view and access to the enterprise. Here is the example of Detroit Edison Energy, their AF structure, which follow the APRI standard for the equipment. You can see the business unit, plant, unit, primary system, secondary system, subsystem, equipment. This is an example of equipment template detail. On the left-hand side, this is a category, equipment category. On the middle side, this is the equipment attribute or parameter. And those data is not necessary only from Pi. You can have data from your material management system or from a table or from a document to reference, or even you can calculate between those attributes to generate a new attribute. Then we talk about event. Event is very important in the power generation business. Event like startup is an event. The creating of analyst event frame is quickly become key to increasing speed to this decision better and the better understanding of the system health. Event frame can be high level, unit trip, or breaker close, or more system level. So this is a typical AF display. And here's the all display in AF. And this example is a boiler feed pump. You can categorize certain type of data as we see before. And this is a Pi F-based analytics tool. This is help you to create an event. So the event frame can be added to the equipment template. The star and the end trigger can be calculation of point or driven by a certain value. You can pick from the performance equation function for building the calculation. You can set how often you want to check for the event and we add the child event. This lets you tell the system to mark the data prior to the event trigger for a specific amount of time. This helps when analyzing what was happening when leading up to the event. Once these are set, the Pi system will automatically mark the data for the event recall. When creating the event frame, you can see and verify the result immediately. And after verifying the event frame, you can tell system to go back in time and create event in the past. Like every time the pump has run or a high vibration event. This way you can get value from event whenever they are implemented for future and past. This is to use our Pi data link in Excel to do some reporting with AF capability. So the report is simplified and based on the element attribute. This one report met with data link is analyzed both event and data. It can be used for each similar asset. But just changing where in AF structure it is point to plant, unit, and equipment when clicked. And you see the beauty of data link is you can replace, once you have a template, you can replace some of the parameter and you can immediately get a new report. Like this is for unit 2. And so we use a simple Excel capability with data link. It's very informative, visualization of data and chart are made. It's all in Excel with our data link tool. This is a sample daily event and production report. You can see those graphics is actually using the condition formatting of an Excel function. But it looks very informative, very good in visualization. This is another daily anomaly report on data and event, highlight and exclusion. Well, here is a scenario. We go through this scenario. I get an email notification, which is derived from event frame on the free water pump. And the email has a link, and that when select bring me to this graphic. So notification can send email to you and link a graphic like this. And you can use your mobile device or any HTML file browser to view this Pi CoSci display. And you want to further investigate on this parameters, you can change to this display. So you can go more detail to those analytic displays for every tag or every event. As we know, Pi can automatically collect data, but sometimes some of data you need to collect by manual. And that data is also very important for correlation, everything together. This is a typical display for a fossil power unit. This is a display in our main machine interface process book. And process book has a playback function. So it will help you to identify any chip event or any event that happened in the past. You can use the video playback function to do that. This is often used in the power generation plant for controllable loads. Often this is used in DCS system. And you may ask why I need to implement in Pi system. Because if I implement in Pi system, this is more like offline system. You don't have to worry about to get any risk to change the unexpected change in the system. So this is a pretty good way to put controllable loads in Pi system and display in process book or in COSI. This is a sample of is environmental screen. It displays the systematic calculation number based on emission limit for the unit. So the data have daily, moving 30 days, and annual numbers. Each threshold level can generate notification. Also, this has button that will bring up the 30-day generation dispatch forecast number with calculation automated emission output. This kept operation and the commercial dispatch group up to date on any environmental limit restriction that may be pending. Well, this is a nice picture provided by our customer Iberdrola on the wind turbine monitoring display. As you may know, the wind turbine wind farm is always on remote area. So central monitoring is widely used Pi to do that. So when you are looking at the private fleet of asset or an ISO managing multiple producer and consumers, OSI enterprise infrastructure, put it all together in a meaningful way of your business purpose. You can see this is ISO, KO-ISO control room. On the left-hand side, this is a lot of display, the train display. This is a process book display. Well, this is one of our customers from India called NTPC. They're showing on the star curve. Basically, each phase of the star has key value that are green when good and red when out of range. So you can see the green is good and red is out of range. It's very easy for you to understand the whole startup process. So they did the same for the shutdown of the unit as well. And this is the energy example. Energy want to do the next level. They want to improve startup reliability and consistency by building up the process in Pi. They systematically check and monitor startup. Why startup optimization is very important? The answer is very easy. Fuel and purchase power, and possible you will get penalty from the market if you already deregulate. After this program, they improved time accurate to 95%. They can graphically monitor the staff using process book. Each box represents task and detailed data is being flagged for analysis. The percent of completion of each phase with the estimation and actual time being recorded automatically. This is also from Entity. With this report, you can see each startup overview and then select to view the detail. The detail shows system performance with its estimation and actual time determine the variance. The detailed pi data can then be analyzed to determine improvement or identify cause of issue. So let's talk about some use case of in T&D, transmission and distribution. So by using Pi can help you on the substation automation, on the planning for the availability, and help you to improve the asset management, provide key information for condition-based maintenance, prioritize outage management, facilitating demand-side management and response, optimizing renewable integration. At the bottom of the new of our key customer who are pushing the technology use curve. Let's look at a PSEG example. At the PSEG, they collect from transmission, distribution, SCADA system, and collect data from MV90 transformer loading, and some manual data, and hydrant data, SAP PM data, maintenance data, and Delta X is the oil analysis data. And everything collect into Pi. So they have all the data into the Pi system. So they use F to build up the tree structure, to model all the equipment. Here is the example for a transformer. And they show all the information using our webpack. PyWebpack is a tool for you to use Pi data in Microsoft SharePoint portal. And you can see they use some percentage on the weighting of the equipment. Sorry, this looks like using our battery. Okay, thank you. Okay. So they also create dashboard, and you can see the dashboard is in the SharePoint. And the data is not only from Pi, some of them are from SAP PM. So our webpack is not just showing Pi data. You can show some relational data table here. And this is a summary of the worst performance LTC. This is to help you prioritize the maintenance requirement. Let's take a look at SDGE real-time CBM project. Well, this project is pretty different from PSEG project because in PSEG project, they didn't spend extra money to install new sensor or new device. They basically just integrate whatever the existing data source. But for the SDGE case, it is a US government smart grid project. So they have a brand new sensor device and communication line, everything. There's a lot of new stuff. So their process is very automatic. So all the visualization, reporting, dispatching, and maintenance it's become a continuous improvement process. This is their AF structure. Based on model-driven approach, they can do calculation and analysis using our tool, PI-ACE. The system is used for reporting, visualization, and analyze the asset in common method. Using AF, you can have all the display. It's become a common one. And Pi, we are trying to use Pi infrastructure as the basic of our business intelligence. So the capability span the grid and the substation or the area profile. So let's see the report. This report is to input Pi data into Microsoft Power View, a very easy business intelligence analysis tool. So you can have an interactive analysis using like area, like transformer use age. By having substation level data and end meter data, the loading profile of the feeder and distribution transformer can be calculated. And once you use the Microsoft Power View, they can connect to Microsoft BIM map and show on the map. You see the analysis. You can choose any of the item to change the line, and this is all in Microsoft Power View. And this is correlated to the map, BIM map. So you can drill down anything in the Power View, and the data will bring from Pi into Power View and the map. Very powerful, huh? So the challenge is still we have so much data and so little time. Another challenge is to analytics based on the statistics base using advanced pattern recognition. It helps locate what is important to focus. Because too much data, we cannot, monitor the data by man. So we have a partner, they have a product called Advanced Pattern Recognition Modeling. This is their system just right on top of Pi. It gets computer to work for you, and instead of you working on the computer. The model can analyze large amount of data running all time and never take break or vacation. is very good at detecting anomalies on critical equipment and systems for early detecting of slow developing failure. Multiple sensor model, not just a single signal threshold, help it avoid failure, supporting operation and optimizing maintenance. So let's look at this one. We use a term called catch. When the system successfully detect and provide early warning of an impedance issue. Here's an example of a catch on a FDF bearing. The system detects a rise in the bearing temperature. And the blue line is the real-time data. And the green line is the model, it predicts the data. And you see this become more and more, there's a big gap here. So if they exceed some sort of range, they will put a rest cross here. And until you accumulate certain amount of X, they will automatically notify you there is a problem and for you to do a check. So after we check, we found this is oil filter is too dirty, need to be cleaned. So after we replace, and we see the green line and blue line is going very close. So this is the use of like a new statistical process control method to do the maintenance, predictive maintenance. I highlight a couple of this value case presented. The National Grid, they estimate a 9 million saving in heat rate and reduction in ISO penalty. And DTE estimate 20 million saving across their fleet and processes. PSEG estimated a 10% reduction in maintenance spend, which is, great value. So at the Verve Energy, they start just a couple of years ago with 1 to 2 initiatives based on Pi system. Each initiative had to be on real ROI. Once the infrastructure was in place, the number of ROI programs grows to 22, building on top of the core system. So this is a quote from customer. When we set off, we define realistic annual saving of around 7 million a year. I think the figure was conservative on what we've been seeing over the last year. I think we have only scratched the surface. So this is a quote from customer. So to close out, the Pi infrastructure power of data is all in real time with historic data access in context from the enterprise to the plant, major system, then subsystem, and to equipment. With event frame, systematically flag, track, and measure key event, perform real-time calculation, and train those results, aggregate real-time data with other information system, and send notification, all providing true dynamic insight to current condition and situational awareness that make us make decisions faster, more accurate and complete, more effective to the business, enable situational awareness, and predictable. Increase the speed of execution, and I believe the key is to cultivate and leverage the collective mind power of organization. And thank you very much for your attention today.